Hey everyone, if you've been enjoying my free math lessons on Prodigy Mathematics, I've got a great way you can support the channel and supercharge your learning. I've launched Martian Mathematics, a growing collection of problem sets, quizzes, and fully worked out solutions designed to complement my videos. These aren't just generic worksheets. Each set follows my lesson structure, reinforcing key concepts with carefully crafted problems and step-by-step solutions. Every purchase helps keep this channel running, so I can continue bringing you high-quality, free math education. Check out Martian Mathematics on Teachers Pay Teachers today. Your support makes all the difference. And don't forget to like and subscribe. All right, lecture 21 is on basic statistics. So what exactly is statistics? Statistics is an area in mathematics where we aggregate data, collect it, we quantify it in meaningful ways so that we can, study it, analyze it. Okay, so data will come, usually it's from large data sources. So for example, in baseball, there's the batting average. So you take a player and you keep record of how successful he is when he's at bat. And this gives you a batting average. And this is to represent the player and how good a batter he is. For example, if someone were to say that the school class is comprised of 40% boys and 60% girls, this is collected from a large amount of data about the students in the class, and it's aggregated into this single number, this percentage of composition. The one you're probably most familiar with is the idea of an average, or a class average, or a personal average. So when you take a class, you receive evaluations, usually reported in percentages, which we covered back in lecture, I don't remember, I'll put it here. And if you've got more than one test or more than one homework, you average those to get your overall grade. Yes? You're familiar with this idea. The technical term for average, as we're calling it here, is called the arithmetic mean. Sometimes just mean or mean value. Arithmetic part means that we're adding stuff up. There's different types of means. We're not going to talk about them today or in this course. This is something that you'll get in more advanced math classes. There are a few means. You have your arithmetic mean, which is the one you're most familiar with, or the average. There's the geometric mean, and there's also something called the harmonic mean. Now these have their utility, especially in problem solving, and you will usually get that in a more advanced course in math. But just to illustrate the idea behind the arithmetic mean, let's consider a class with some kids in it. Here is a ruler, and we're going to report their height as 60 inches. Now, let me be careful here. There. So here are the students in our hypothetical class. Notice how they are all 60 inches tall. And so if I said, what is the average class height? Maybe you need to purchase some t-shirts for some school function, and you want to get shirts for everybody. You need to know what size to get, or hats or something like that. And let's assume that there's a correlation between your height and the hat size, which there's not. But some people have big heads, some people have small heads, but it's hard to draw head sizes. But if I asked what the average height of this class is, what would you say? 60. 60, right? They're all 60. They're all 60 inches tall, so the average height is 60 inches. That just makes good sense, yes? So the little parentheses there, the quotation marks there at the end, that's for inches. It's a standard symbol to write inches. What if it didn't look like this? What if instead we had something like so? Where I've kind of arranged people from shortest to tallest, yes? Now I ask you, what's the average height of the class? Well, you can't say just by looking, but the idea is that you imagine taking this line that I've drawn and adjusting it, right, until the distance below is the same as the distance above, yes? It kind of suggests an idea called the median that we will talk about shortly, but I want to stick with the mean for now. How can we add these, how can we mathematically calculate their average or their mean? And the formula for the mean, so I'll just say the mean is equal to the sum divided by the number. So what does that mean? Well, here we're talking about average height. So we sum or add up all the heights, and we divide by how many different people we had. How many different height measurements did we take? And so maybe, let's put some numbers on this. Let's say this guy was 50 inches. this guy was 60 inches, and this guy was 70 inches. And so we add these up, 50 plus 60 plus 70, and we divide by the number of people, 1, 2, 3. Can anyone add these quantities up? Well, they're all in 10, so that's nice. So we have 6 tens, 7 tens, and 5 tens we have to add. What do we get when we add 6 tens to 5 tens? 11. What do we get when we add 11 to 7? We get 18, not 110. Hence the answer is 180 inches, right? So we get 180, and these all were in inches, by the way, so I should put my units on there. 180 inches divided by 3. Well, what is 180 divided by 3? We've already learned how to do long division. We can do that. We may recognize that it's really a quite easy problem if we think about how many 3's go into 18.
It's 90.
Yeah. What's what?
Oh, I don't know.
What is 18 divided by 3?
60.
So 6. And so 180 divided by 3 must be 60. Now look at that. We had earlier a class where everyone was 60 inches tall. If we were to add all their heights up, we would have got 180. We would divide by 3. We would have gotten 60, right? And that would have been, well, kind of a waste of time because we already knew if they're all 60 inches tall, the average height is 60 inches, yes? Just based on our normal sense of what is average, right? You would never say, well, this tall guy here, he's average height because he's tall. Yes? So it's just our kind of common sense notion of the idea of average height I want to bring to bear. And then I want to emphasize what the formula is and how it relates to our intuitive notion of average. And that's what I was trying to express when we talked about moving this ruler such that it's equally higher than this guy as it is lower than this guy. Yes? It's kind of this balance, if you will. And so technically what the average is, or what it tells us, is it says, hey, take all of these students, because this could be thousands or hundreds of thousands of students. We would add up hundreds of thousands of heights and divide it by 100,000, and we would get a number just as simple as this. And what it tells us and why we use it and what statistics does for us is it says, well, in this instance, replace all of those individuals, which are many, by 1, that you can just multiply by the number of people that you suppose is in the class. So we create this kind of ideal individual, this person that is exactly 60 inches tall, and we say, well, I can think of my class now as all these people, replacing them with this average person times n, however many students there are in the class, you see. So it's important that the average value, when multiplied by the number of students, gives the sum of the individual heights. Does that make sense? Because then we can just talk about the one student, because they kind of represent all of them in as far as their height goes. Yes? Okay. And that's the idea. That's why you do it. So the batting average, it represents the whole history of this person's time at bat and tells you what you expect them to do or how well you expect them to perform. Or at least it tells you how well they performed in the past. Who knows? Maybe they're going to have an off day and they're going to miss it. Or maybe the guy that never hits anything is going to get a home run. That can happen, of course. But it does tell you about the history, right? This tells us about the group as a whole. So we would say, yes, well, these, are, since 60 inches is 5 feet, that's pretty short, we would assume this is a class of young kids and not college students. And certainly not a class of Vikings or something, right? So that's the idea there. So the mean is simply the sum of all the individual measurements that you make, whatever we're talking about, height, grade, whatever it is, and then you divide by the number of items that you've added up, okay? So if I add up 7 items, I divide by 7. If I add up 2 items, I divide by 2. Yes? So let me use this idea of average, right? So to kind of come up with a class average. So if I said, hey, there's Alice and she has a class of math students, and you might be interested, well, how well is the class, how's the course going? How well do the students do? Are they really good students? Are they bad students? Well, I could tell you all of the grades. I could say, well, student 1 got an 80 and student 2 got a 100 and student 3 got a 60 and student 4 got an 80. And then if there were like 30 kids in the class, you wouldn't have a good idea of how the class is doing. You'd just hear a bunch of numbers and you probably would have forgotten, the 17 or 18 previous numbers that you just heard. But if I were able to quantify how well the class did on a particular test, let's say, maybe they took their first fraction test and want to know how they did. How'd the class do? Not how did Jill do or how did Frank do, but how did the whole class do? Then you can use this idea of an average or a class average to quantify that, and it'll give you some idea, yes? So we can do that to these grades that Alice has here, so all we have to do is add these up. So what is Alice's average? Well, we would take the 80 plus the 100 plus the 60 plus the 80 and divide by how many? 1, 2, 3, 4, yes? Can anyone see how to do that math there? Is this obvious? So we get 100. We can think of it as, again, since they're all factors of 10, we can just add up tens. We have 8 tens and 10 tens and 6 tens and 8 tens. So what is 8 tens and 8 tens? That's probably the easiest one to start with. 8 and 8 is 16. Okay, and what is 16 plus 6?
22.
Okay, and what is 22 plus 10? 32. So this is 320, right? So we get 320 divided by 4. Well, 32 divided by 4 is 8. So 320 divided by 4 is 80. So remember, these were percentages. I don't want to write the percentage for each one because it's cluttering, I think. That means the class average is 80%. And for most schools, they'd call that a B. So if I said, how did the students do on the fraction test? And they said, well, the class average was 80%. I'd say, well, that's not too bad. Sounds about right. It's a well-designed test. If it was a too easy test, fraction's kind of a hard subject. If everybody got, 100 and the class average was 100, I'd say, well, you made too easy of a test. If the class average was 40, I'd say you made too hard a test. You need to go back and either recover that material or make an easier test, because if your class average is 40, something's not right. Yes? So Alice's mean is 80. So I'll just put this up here. I'll write the mean is 80. And I'd like you to try Bob's class average and Charlie's class average. So go ahead and I'll stand over here so you can see the numbers. Pause the video, try that now at home, come back when you have your answer. Okay, let's do Bob first. So Bob's class, we had a 69, an 86, a 79, and another 86. And that again is 1, 2, 3, 4 tests. So we'll divide this by 4. So this one a little harder to add up. We could do a long addition, yes? Or we could try to be sensible about this. Sometimes you can move numbers around to make things make more sense, right? So if I take 1 away from this 86 and give it to this 79, that makes this an 80. I could take 1 away from this 86 and give it to this 69, make that a 70. That would leave me an 85 here and 85 here. Then I have 80 and 70 here. I could bring this up to 80. If I took 5 away from here and 5 away from here, that gives me 80, 80, 80, 80. 80 4 times, 320 again, divided by 4. Nice. Bob's class also got 80%. The scores don't look the same though, do they? They look quite different, yes? And we'll get to how do we characterize the difference, because the average doesn't tell us everything. If it did, we would say, well, Bob's class and Alice's class are identical. But we know they're not because we can look at the actual tests and we see those are not the same test scores, yes? But they do have the same average or mean. All right, now let's do Charlie's average. Well, Charlie's class, we had one score of 80, one score of 90, one score of 70, 1, 2, 3 students in his class, so we'll divide by 3. Again, this is not too bad. What do we get when we add 8 and 9? 17. And when we add 17 and 7? 24. So this is 240. So 240 divided by 3. How many 3's go into 24? 8. So 240 divided by 3 is 80. Again, 80%. Amazing. So all 3 of these classes have a mean of 80%. Yes? So clearly the mean doesn't tell us everything because this class didn't even have as many students, did it? But that shouldn't matter, should it? Because the average is supposed to be reducing the class to a single student, that if you multiply times the number of students in the class, you get the same sum, yes? Before we leave the arithmetic mean, I just want to mention that we actually saw an example of this mean back in lecture 17, when we did graphing. We had the midpoint formula, yes? And the midpoint formula was an average or a mean. But I want to return to that idea with the students and their heights, where I took the short kid, put him on the left, and I took the middle-sized kid and put him here, and then I got the really tall kid and put him, well, I didn't make him tall enough. He got a really long neck, huh? It's like a giraffe man, huh? And I thought, all right, well, I want to find a way to take my ruler. There's an awfully big ruler. And here it is, if it's just touching the top of this guy's head. If it touches the bottom of this guy's head, it's here. I want to find this kind of compromise somewhere in the middle, right? And so this idea of trying to find the middle is the idea behind what is called the median value. And it literally means in the middle. If you've ever driven down a road and seen this like divider in the center of the road that usually has grass or something like that, or maybe some trees, those are sometimes called medians. It just means in the middle. And so that's what this idea gets to. And how do we do it numerically, though? That's what we'll show next. Because we can do this, these heights, we'll forget about that now. And I want to try to get the median values for Alice's class, Bob's class, and Charlie's class. And I'm going to start with Charlie's class. And I'll explain why once I've done it. So the first thing that you do to find the median is you arrange the values in order from lowest to highest. So we'll have to look over here, and as we see, the lowest score in Charlie's class was 70. So I'll write that one. And the next would be 80, right? So I'll write that down. And then finally, we had a 90 was the highest score in the class. And so to find the one in the middle, we need to pick, we start with this element here. This has 0 scores less than it, but has 2 scores greater than, yes? Okay, that's not the median. This has 1 score less than and 1 score greater than. This has 2 scores less than and 0 greater than. So which one is the one in the middle? 80. So this is our median value. The magnitude of these numbers does not matter. It's when ordered, we have an ordered list, the median will have as many entries to the left as it does to the right. Does that make sense? Yeah. And that's called the median value. And so the median value for Charlie is 80%, the same as the arithmetic mean. When I look at Alice's list, however, let's see. Alice, the lowest score was a 60, so we'll put that one first. And then we had an 80. And then we had another 80. And then we had 100. Yes? So we can go through this again and try doing what we did with Charlie's class. This has 0 less than scores and 3 greater than scores. This has 1 less than score and 2 greater than scores. This has, well, is that right what I just said? I said this has 2 greater than scores. No, that's not right, is it? This has only 1 score greater than, yeah? And 1 score less than. Because the score to its immediate right is exactly the same, isn't it? Yeah? This one also has 1 less than and 1 greater than. So it seems fitting that 80 should be the median value, yes? But there's a complication. What if instead of this being 80, what if this was 79? How would we do it then? Because 79 would have 1 less than and 2 greater than. 80 would have 2 less than and 1 greater than. How do we manage that? See, there's a problem when you have an even number of entries. When you have an even number of entries, what you do is you take the 2 in the middle and you use the arithmetic mean on those alone and replace those 2 elements with a single value, which is the arithmetic mean. And that's your median. Okay? Because when you have if you've done Minecraft, right, when you're trying to build something, you want to figure out where to put the door, right? You want to make sure that your wall is odd size if you want to have a door in the middle, unless you want a too wide door. This is the too wide door. So I put back the 80 value so we can get a true evaluation of this. So we would simply replace these two values with 80 plus 80 divided by 2, because we're averaging these two items in the middle, yes? And I don't think it goes without saying this is going to be 80, right? Because 160 divided by 2 is just 80 again. And so look at that. In Alice's class, her median is also 80%. Okay, I'd like you to find the median value for Bob's class. So go ahead and pause the video, come back when you have your answer. Okay. All right, so first thing we do is put Bob's class in order. So the lowest score is a 69. The next highest score looks like 79. After that, we've got an 86 and another 86. So notice that it's an even number, yes? So in order to chop this in half, right, I need to average these two values, yes? So the median will be 79 plus 86 divided by 2. And what do we get when we add those up? We can pretend, right, make life a little bit easier that what we really have is 80 plus 85 by taking one away from the 86 and giving it to the 79. To make it a little nicer. So we've got 80 plus 85. That's going to be, well, if it was 80 plus 80, it would be 160. Put that 5 back in, 165, right? So we get 165 divided by 2. Well, that's not the easiest number in the world to half, now is it? If we take half of 16, we get 8. And if we take half of 5, well, we would treat that like a 4. We'd get a 2. And then we'd have to add a decimal point to rectify it fully. Or we could just do simple long division. That may be the easiest way to show it. 2 divided into 165. We'll need to put a decimal point in because we're not going to get an even number or an even answer because 165 is not an even number, so it's not going to divide evenly, right? So 2 goes into 16 8 times. It's a funny looking 8. Leaving a remainder, of course, of 0. 2 goes into 5 2 times, leaving a remainder of 1. 2 goes into 10 5 times, and so we get our 82.5. It's a decimal number, but that's okay. We know how to deal with decimal numbers. We did that back in lecture. I really should bring a list of the lectures that we've done so I can cite them. So Bob's class has a median value of 82.5%. If we were going to evaluate how well the three classes did based on arithmetic mean, we would say they all did the same. If, however, we were to evaluate how well each class did based on their median score, we would conclude that Bob's class did better. And Charlie and Alice's class did the same. So it seems that we still don't have a full picture of how to quantify the differences between these classes, given that their arithmetic means are all the same, and at least for 2 out of the 3, the medians were the same. There's one last concept I want to bring up. We're not going to use it a lot, but it's called the mode. And the mode will tell us which value occurs most often. Now this, sometimes one of the downfalls of it is you may not have any repetitions. If we look at, say, Charlie's class, everybody had a different test score, yes? So there isn't a single test score which occurred most, yes? But if we look at Bob and Alice's class, we would create a table of values like this. Let's do Alice. So Alice's class, we're going to find the mode. And what we do is we create a table of values and we record the frequency or the number of times each one occurred. So we could do it ordered, it doesn't really matter. Because usually you would create this table and then you would reorder it by the second column, the frequency, how many times it occurred, how frequent it occurred. That's what frequency in this case means. So our first table, we'll just do it in high to low order. So 60 was the lowest score. How many 60s did we get? Well, we only got 1. Then we had an 80. And how many 80s did we get? Well, we had 2, you see? And then we had a 100. And how many 100s did we get? We only got 1. So the mode, in this case, is 80 because it occurred twice. Yeah? So the mode for Alice's class is 80, or 80%. So I'd like you to calculate the mode for Bob's class, the data over here. So go ahead and pause the video. Come back when you have your answer. So again, making this table of values, the lowest score was a 69, and that occurred only once. And then we had a 79, which also occurred only once. And then we had an 86, but that occurred twice. And so the mode for Bob's class is 86. Does that make sense? So we cannot really get a mode for Charlie's class. One thing you can do is you can repartition grades. You can say, all right, well, how many grades, fell in the range of, well, in this case, it'd have to be a really broad partition, right? How many are less than 50? Well, that'd be 0. How many are greater than 50 but less than 80? Well, then you'd get, well, less than or equal to 80. Then you'd get 2 values. How many are greater than 80? Then you'd get 1 value. So you'd say that the mode was the range 50 to 80. But we do see the mode, which is higher for Bob's class, 86%, versus Alice's, in which case the median, the mode, and the mean are all 80%. Yes? All right, the last metric that we have that I want to bring up in statistics is called the range. And the range is simply the highest value minus the lowest value. It kind of gives you an idea of how wide the distribution of scores are. Now, of course, in more advanced statistics, there are much better metrics to give you that width of grade distributions or distributions called the standard deviation. But we're not going to do that. We're not going to cover that. That's a little too advanced for this class. But the range is a fine start to that. And so if we evaluate the range on these 3 classes, let's start with Alice's class. The range, well, the highest score is 100, and the lowest score is 60. And so the range is 40. I'd like you to calculate the range for Bob's class and Charlie's class. So go ahead and pause the video. Come back when you have your answer. Okay, looking at Bob's class, the highest score in Bob's class was an 86. And the lowest score in Bob's class was a 69. Now, who can do 86 minus 69 for me? Well, we can do it. It was probably in lesson 2, I'm guessing, where we learned to, no, maybe lesson 3. Oh, I don't know. One of the earliest lessons we learned how to do subtraction. So we have 6 minus 9. We can't do that. We have to borrow. So we'll borrow from our neighbor, making this 16. And what is 16 minus 9? That would be 7. Then we do 7 minus 6. Well, that would be 1. And so we get our answer that 86 minus 69 is equal to 17. So that's the range in Bob's class. Yeah? What about Charlie's class? Well, in Charlie's class, the highest grade was an 90. And the lowest score was a 70. And what is 90 minus 70? Yes, 20. 20. So the range for Bob's class was 17. And the range for Charlie's class was 20. So we can see that now we kind of see the differences here, right? Bob's class had it had the tightest range, right? Most of the students scored within a narrow window of each other, yes? Whereas in Alice's class, very broad range, right? I mean, there are 40 points, right? It's almost the difference between passing and failing, right? So quite a broad range there. Charlie's class is comparable to Bob's class. It's more like evenly divided. They had like one poor performing student, one really well-performing student, and then kind of an average student, what we'd call it, right? That's those 3 grades there. Bob's class, as indicated by the range and the high, median, and mode, seemed to be, the class average seemed to be getting pulled up from the top, right? These 286 is what did it for them, right? They pulled the average up. Whereas in Alice's class, we seem to be mostly average students with one exceptional student and one poor student, yes? And so that is how we characterize these 3 different classes using the methods of statistics: the arithmetic mean, the median, the mode, and the range. Okay. Next time, I think we talk, what are we going to talk about next time? It's got to be combinatorics. Next time, combinatorics or counting, how to count things. Okay, not how to do 1, 2, 3, 4, 5, but how to count things. How many different ways are there to do this or that? All right? So how many different ways can you make an ice cream cone with 3 flavors of ice cream? Yeah, that's combinatorics. And so that'll be next time. So I'll see you then.